Good. So this is the example which I want us to handle today, and it's an example that is related to employees, that is salary. Okay. Yes. So let's suppose, or let us suppose, that we have a company with roughly 100 employees. Okay. So here we are dealing with a company with how many employees? 100 employees. Okay, so let me say our n here will be 100. Okay, good. And multiple salary structure. Okay, according to specific job roles, the salaries are generally distributed with mean. We have a mean of 60, that is 60,000 US dollars is our mean. Okay, so here we have our mean. In fact, we are given the mean of the that is of the salary. Okay, and the mean it's what? And the mean it's that is 60,000 US dollars. Okay, and we have a standard deviation. We have a standard deviation of 15,000 US dollars. So we have standard deviation of 15,000 US dollars. Okay, so we are being asked, what is the probability of a randomly selected employee earning what? Earning 40, that is 45,000 per annum, US dollars per annum. Okay, so definitely this is annual salary. Okay, sorry, I did not that is add that in the question, or but basically know that this is what? This is salary, that is this is salary, um, annual salary. Okay, okay, this is annual salary. Right. Now in this case we want now to check, that is the formula for that is formula for normal distribution, or normal distribution formula. This is the normal distribution formula. Okay, and I will give you the that is the hardest task. Okay, I will give you the hardest task here, and the task will be now on your side. Please try to do what? To do that is all to do this. Don't know why it is not pasting. So the task here, or the task which I will give you, it is the task of doing that is the practical, using what? Using the mathematical way. Okay, like you will have to break down. You will have to break down this. You will have to break down this um, equation. Okay, or formula. Don't know why it is not picking, but I can as well do a screenshot. Let me just do a snippet of the formula. Mm, don't know why it's not picking. The formula. Just a minute. Don't know why it's not picking. Just a minute. Nice. So here is the formula. So I want you to break down this formula, okay? I want you to break down this formula into all these parts, okay? Like we'll have of course the part with the standard deviation, okay? That is the STDEV, which is the sigma, okay? I will also need you to do square root of 2 pi, square root of 2 pi. I will also need you to do, of course, now we are done with this part. I'll also need you to do this part, okay, which will be x, minus mu, which is
Yes.
the mean. Okay, someone has a question?
No.
Naomi?
Oh, my apologies. No, no, no. I don't have a question. I think I muted by mistake.
Okay, all right. You will also come and do this part. I'm just trying to help you on how you will simplify, okay, on how you will simplify this formula. I want you to do now that is the practical part, all the mathematical method, okay. Yes, then after that you will also come and now do that is the x minus mean divide by is it sigma, which is the standard deviation, okay. After that I will also need you now to come and do this. Once you do this, now you will have to square it. You will have to that is in now say raised to what, raised to 2, okay. Then after that you will now have this multiply by what, by a half, okay. We'll also have this multiplied by a half, okay. So meaning you at this point you will have all these parts, okay. You'll have this part. Now the that is the other part will be, someone has a question, please zoom, okay. Okay, so on this part you will now have that is this part of the exponent. Then after that you will now find, let's now call this maybe x, let's call this, or c, let's call this formula c. So after that you will be now able to find what we call that is exponent of what, of c, exponent raised to power negative c, exponent raised to power negative c. So this one will be this part, okay, from here up to this part, okay. I've just simplified this, okay. Otherwise you can I can still use this to that is instead of c, but I've just assumed just to simplify the that is the formula, okay. Or maybe let me just do it. So it will be uh, now exponent raised to negative this, into brackets. Let me just close this into this. Okay, so this part will be all this part, and you will be having what? You will be having this, and you will be having this. So we can now say the last part will be now 1 divide by, okay, 1 divide by standard deviation into that is standard deviation multiplied by, okay, square root of 2 pi, okay, multiplied by square root of 2 pi, that way. Okay, then you will have now your last part. Okay, now your last part will be multiplying this and this. Okay, multiplying this and this. If you multiply this and this, you will now get what? Your probability. Okay, that is function of x. You will now get the function of x. Is that clear? I was just showing you that how you will break down that formula, okay, for you to do it mathematically. Okay, it's up to that point. Is it clear? The way I've broken down the formula. Heini, good. Jesse, good. Michael, good. Eric Otieno, good. Nice. So please go and try that. Okay. Nice. Then, what are our values of what? What are our values of what? What are our values of x? Okay. Remember, we'll need some probabilities here. Okay. So, I want us now to generate or to randomly. Remember, we did a random selection here. What will be the probability of a randomly selected employee earning what? Earning that is 45,000, okay, US dollars. So I want us now to generate like that is a random salary, okay. I want us to generate like a random salary of, let's say, 10 people, okay, or of 10 employees, okay. I would have done for 100 employees, but I just want to generate that is like a salary of what? Of 10 employees. Okay. So let's assume we have X. Okay. This is our X. X meaning it's what? The salary of the employees. Okay. So in this case, salary of employees will be what? Will be our X. Okay. So we might decide maybe to start with, let's say, that is 10,000 US dollars. Okay. And then after 10,000, I want us now to go with what? Let's assume the least paid person is paid 10,000. Okay. 10,000 US dollars per annum. Okay. Yes, 10,000 US dollars per annum. All right. So this will be now, and I want maybe to increase it by what? By that is a salary gap of, or by interval of 5,000 US dollars. So I'll say this plus maybe 5,000. Okay. Yes, so we have all that. Let's check. I only need 10. Okay, I will only need 10. Yes. So this is that is random selected, or let's say this is salary of what? Of how many employees? Of um, of 10 employees. Okay, out of 100 employees. Good. Now, When calculating, that is when calculating um, normal distribution or probability of a normal distribution, definitely we usually we will need mean and we'll need standard deviation. And this is already provided in our what? In our question. Okay. If it wasn't provided, then we could take average of what? Of our total employees salary. Okay. If maybe we are assuming we had 10 employees, then we could take the average, that is the average salary of what? Of these employees. And in this case, you can see we could take, that is a salary employee of that is a salary of our an average salary of 32,500. Okay, which is the mean. Then we could also find the standard deviation of the same. Okay, but we are already given the mean and the standard deviation. Okay, so no need for us to do what? To calculate that is these parameters. Why? Because we are already given. Good. Now I'm going to use Excel inbuilt, that is Excel inbuilt function to do what? Now to calculate the probability that an employee or a new employee will be paid 20,000 or 30,000 or 45,000. Okay, so using normal distribution. Okay, using normal distribution. In fact, let me try and add, that is increase this. Let me increase this. Let me increase this up to maybe 30. Yes, let me increase this up to 30. So that will be here. Okay, good. Now we need the normal probability. Okay, or we assuming we need the probability that an employee will be paid 80,000, 40,000, or 10,000. Okay, using normal distribution. Okay, so our function of x will be now we will now use the that is the Excel inbuilt function. For your case, you can as well try what? This mathematical, that is way, all this mathematical method to calculate and see whatever you get here. Okay, whatever you will get here, if it is the same value with when you use what? The inbuilt Excel functions. Okay, just to cross check your accuracy. If you get the same here, the same value, okay, then it means your procedure and also your computation were what? Were correct. Okay, nice. Now I want us to calculate the normal probabilities. Okay, of all these employee salary. Are we together up to that point in terms of our objective? Are we together in terms of our objective? We are good. Nice. Thank you. So with that now, I'm going to use the inbuilt function known as normdist. Okay, normdist. So normdist will return normal distribution for the specified mean and what? And standard deviation. Okay, yes, so now we are going to use this normal distribution. I will increase, that is my x. I'll zoom in. Let me first do away with the formula so that I can zoom in. so that you may capture the function. So it will be norm dist. Okay. Then after that, you can see it is requiring us to enter the x value, which is this. Okay. Then do a comma. After that, we'll need what? Mean. And we are given mean here as 60,000. Then comma. And we are given standard deviation. Okay. We are given standard deviation as what? As this. Okay. Good. And then comma, we'll need what? We'll need probability mass function rather that is but not cumulative distribution function. Okay. Remember I had explained that is the difference. Okay. So for us, we need the probabilities. So you are going to select now the probabilities and then close, and then you can enter. Okay, good. But we have to do what? We have to log or reference these cells. That is the H3 and J3. Okay, so with that, we are going to use the dollar signs to log. We are going to use the dollar signs to log these two, that is cells. Okay, yes, to log these two cells. And then we are now good to do what? To drag down. We are now good to drag it down. Okay. Then you can see how the probabilities are looking like. Okay. You can see how the probabilities are looking like. They are very small. Okay. If they are small, what does it mean? Does it mean we used a very high mean or a very low mean? Okay, because when we check the average of these, okay, you can see we are getting an average of 82,000, okay, 500. Does it mean we are using that is the wrong what? The wrong mean, okay, and the wrong standard deviation? But let's not assume that. Why? Because we are already given what? We are already given that is the standard, okay, the standard values. Okay, yes, we are already given the standard values. So basically now these are the probabilities, okay, for what? For a person getting a salary of 65. Okay, and remember this is only for this is probability for only 30 people. What if maybe we increase this? What if we increase this? What will our that is our what will our probabilities look like? Will they increase, or how will the probabilities basically look like? Okay, so you can see the probabilities are increasing. Okay, that is the probability are decreasing. Sorry, the probabilities are decreasing. Why? You can see the number of decimals are increasing as we increase what? As we increase the salary away from the mean, okay, from the mean salary. So let's try and see that is the probability of salaries around what? 60,000, because remember we said the mean or the average salary is what? Is 60 of all the employees is 60,000. So you can see the probabilities are high around this that is around this salary range. Okay, you can see around this the salaries are what? That is the probabilities are that is are high. Okay, let me try and use what? Let me try and use um, conditional formatting. Okay, so I'm going to the smallest, that is from the smallest to the largest. So you can see our probabilities. Let me admit someone. yes, you can see our salary, okay, or our probabilities are high within where we are having what? Our average salary, okay. What about if we use maybe the true average, okay, or we can just compute what? The average and the standard deviation of what? Of this, okay. So let's try and compute that. So here now we are going to use the true mean, okay, which will be equal to average, okay, average of the salaries. This will be the average of the salary, okay. And then we will now also here have the standard dev, okay, the standard dev. Here now we are going to use that is sample, because we have only taken 30 entries out of what? The 100 entries, okay. So in this case here we are dealing with us with the sample data, so we'll need the sample standard deviation, okay, and close that, okay. Now we have this our new salary average per annum, and this is our standard, that is our standard deviation salary. Okay, so with that you can see even that is that is the probabilities have shifted to around where we are having our that is our mean, okay. So you can see the probabilities are high at this point. Whenever you can see a green, okay, meaning that is the probability of getting a salary, or of a new employee getting that is an average salary. It's what? It's high around that is 80, 75,000, 70,000, that is and 65,000, okay. So in this case we know the probability, okay, the probability of getting 65, a salary of 65,000 US dollars per annum is this value, okay. Then probability of getting 95,000 US dollars as your salary, okay, it is this. Then the probability of getting a salary of 10,000 US dollars per annum, it's very low, okay. You can see it's very low. Whenever we are having red, it means we are having a very that is a very low probability, okay. What about when maybe we try to plot this, okay. Let me try to plot this and see how it will look like. And since it's a normal since it's a normal distribution, okay, I'm going to use what? A line graph, okay. You can see now, you can see our salary, okay. Our salary, it's normally distributed, okay. It's kind of normally distributed. You can see how the trend line is looking like, okay. So if maybe we increase and decrease the values here towards 0, okay, we will get what? We'll get that is this kind of what? This kind of we'll almost get a perfect what? We'll almost get a perfect normal distribution, okay. As we increase towards 0 and towards as we increase further the salary what? The salary range, okay. So you can see now we have a normal distribution, or we can say this that is our salary, okay. All the salary of the 30 employees are normally distributed with mean salary of 80,000 and a standard deviation of what? Of 42,000 US dollars, okay. Yes. And then the probability, you can see the probability is high at the point where we are having what? Where at the point we are having the average or the mean salary. Okay, yes, good. I want us to check, this is the mean salary. What about when we shift or when we reduce and increase the what? The mean. I want to see how a mean affects that is normal distribution. Okay, so basically, from my knowledge is that mean, when we change the mean, will bring an horizontal what? It will bring an horizontal change, okay? Will bring an horizontal change to the what? To the mean, okay? It will bring an horizontal change that is to the normal distribution, okay? I don't know if I can try and create a new what? A new probability here, which maybe I can also create a new what? Use a different mean and see how that is the normal distribution will behave. Okay, so let's assume this is the standard normal distribution. This is the standard normal distribution. What about we do that is another distribution now with what? A normal distribution, but with less or with a low value of what? Of mean. So we need low mean, maintaining, while maintaining the same what? While maintaining the same standard deviation. Okay, and also we'll need another one with what? I mean. Okay, and see how the normal distribution curve will behave. So in this case, we can use a low that is, or a less mean of uh, 40,000, and this we can use another one of 120,000. Okay, while keeping standard deviation what? Constant. So in this case, it will be equal to a normal dist, okay, normal dist. Then we need the x will remain. We need the mean. Our mean will be this, and we will maintain our standard deviation. And then we need what? Probability mass function. So for our case, we'll have to log that is the reference of mean and the reference of that is the reference of standard deviation. Okay, we'll have this, and then we can drag this. We can drag this down. Okay, and then we can still, maybe we'll do that is we'll do a one graph. Okay, we'll do a one graph. Let me try and see if it will really plot. Nice. Okay, we'll also need another when that is the behavior when we are working with what? When we are working with I mean. Okay, when we are working with I mean or I value of mean. So in this case, it will be that is I can just copy this. Can just copy this. I just want to be lazy, and then I will adjust this. Okay, I will adjust that, and then these will be our new probabilities. Good. Now let's try and plot normal distribution curve and see what impact will mean and that is will mean have. Okay, so this is our normal distribution curves. Okay, this is the standard. You can see, even if even when I that is I select it, you can see the data which is selecting. Okay, when I click the blue line, you can see it is our standard data. Okay, what happens when we increase the standard or when we increase the mean? while maintaining what? While maintaining while maintaining the standard deviation. So you can see the normal distribution curve is shifting to the what? It is shifting to the right. Okay. When we try to decrease the mean, then that is our distribution will bring what? Will bring a shift to the what? A shift to the left of our standard normal distribution. That's why I say that change in mean, okay, in a normal distribution will bring an horizontal shift of the normal distribution. So it's like this normal distribution when we increased that is the mean, okay, it is shifted to the what? To the right of the distribution. And when we reduced the mean, okay, it is shifted to the what? To the left of the that is of the normal distribution. Okay, so this is for the case of that is controlling normal distribution with what? With mean. Okay. What happens when we control it with what? With standard deviation. Okay. Controlling it with standard deviation. So I want just to have this data and copy that is to this part and see what will happen when we control that is the normal distribution with what? With of course I'll have to carry this. This is our standard. This is our standard distribution. Okay, so I will have this, but now instead of controlling it with what? With mean, I will control it with what? With the standard deviation, meaning we'll keep mean at constant, okay, but vary what? Vary our standard deviation. So in this case, definitely it will bring that is a vertical what? A vertical change. Okay, any question up to that point? Are we moving together? By a show of thumbs up. If we are together, Rose, Bell, Amy, Jesse, only three, four, good. We are good. Nice, thank you. So I want us now to check when we vary with what? With standard deviation. How it's our normal distribution happening. Like we are trying to check how mean and standard deviation affect what? Affect normal distribution. So in this case, I want us to select maybe a standard deviation which is less than that is the standard that is standard deviation we used for the standard mean, and also when we try it with what? With let's double it with a high value. Okay, so this will be 84. Okay, a high value of what? Standard deviation. So here we are going to maintain our standard, that is our mean at standard. Okay, so since I don't want a lot of work, okay, in rewriting that is that is the formula. Okay, I'll just edit it. Okay, I'll just edit that is the formula. So I will have that. Okay, and also I will have this. Now this, when the standard, you can see we are maintaining mean to be as a constant, but we are varying what? Our standard deviation. Then also do the same here. Okay, then after that I'm just going to drag this down. Okay, I'm just going to drag this down. So this is with let's say with small s, that is std with a big value, let's say with a big value of std. Okay, this one was with small value of mean, and this with a large, in fact large value of mean. Okay, this is with large value of standard deviation. Okay, let's try and see what will happen to the what, to the, that is to the uh, normal distribution curves. Okay, so I'll go to recommended, and then I'll go with this. So you can see how that is the normal distribution it's looking like. Okay, so let's start with the first one. So this one, it's when we have what, when we have a small, that is a small standard deviation, we'll have definitely a high peak of our normal distribution, and what, thinner tails. You can see as with the peak it's high. Okay, you can see the what, the tails are becoming thin. Okay, but whenever we are, and that is we are making the, that is the standard deviation more large. Okay, the curve now tends to what, to flatten, or the peak of the what, normal distribution will do what, will also reduce. Okay, compared to the standard normal distribution. Remember, this is the curve of standard normal distribution. When we use that is a small standard deviation, you can see it's like we are increasing the peak and reducing the tails. Okay, compared to the standard normal distribution. When we use a large standard deviation, it's like we are reducing the peak and trying to thicken the what, the tails of normal, of the new distribution. Okay, in comparison to what, to the standard normal distribution. Okay, and that's all about normal distribution. Any question up to that point? Any question? Are we all good? If we are good, we can now jump to and start our last topic, which is hypothesis testing. Okay, so I will share this. I'll make sure I remember to share this. Okay, so I'll share this with you before that is the class ends. Okay, so I'm going to save it so that I can share it with you. So let me open the, that is the hypothesis testing and notes. Okay, good. So for the hypothesis testing, it will be more of that is theory, because we are just trying to learn what, the concept. Okay, that is the concept of hypothesis testing. How do we perform hypothesis testing when maybe we are doing what, when we are doing our research? Okay, remember, mostly hypothesis testing will come when doing that is hypothesis that is testing. Okay, yes, Benson, I can see you have raised your hand, or maybe it's
No,
by mistake. Yes,
no, it is by mistake. Sorry for that.
okay, no problem. Okay, good. Now I know most of you have come across hypothesis testing. And under hypothesis testing, we only have two major types of hypothesis testing. That is the null hypothesis and alternative hypothesis. Null hypothesis always tries to like show there is no significant difference between what you are trying to claim, or that is in your research. Basically, it's showing there is what there is no significant difference, okay, or effect within your your study. But for alternative, that is hypothesis, always shows us there is a difference, okay. It shows us there is that is a significant a significant difference between what you are trying to study, okay. And what is hypothesis testing? So hypothesis testing, mostly it's one of the best inferential or that is a kind of statistics used to make what conclusions, or to infer your results, okay, and which definitely will help you to make decisions, okay. So hypothesis testing, it's a formal procedure of investigating. This is the word which I was searching for, okay. It is a formal procedure of for investigating our idea or our statement or our research, okay, or our maybe research problem or research topic, okay. So hypothesis testing, it's a formal procedure for investigating our idea about the world using statistics. It is most often used by scientists to test specific predictions called hypothesis. Like you are trying to create a scenario, you are trying to create that is a theory, okay. Yes, so or you are trying to get what? In fact, you are trying to create a scenario or a situation. Okay. Yes. So, what about the null hypothesis? Okay. So, the null hypothesis is the claim that there is no effect in what? In maybe in population or in whatever you are trying to what? To research, okay. Then null hypothesis is always denoted by what? H naught, okay. It's always denoted by H naught. For alternative hypothesis is always denoted by H1, okay. Or null hypothesis can be denoted as, that is A naught, okay, or A theta, okay, 1 A theta, that is A theta 0, that is A theta 0, or A theta 1, A theta 2, depending with what? With what maybe you want to use. But let me use this standard method, okay, or method of presenting a null hypothesis and alternative hypothesis, okay. So null hypothesis basically shows us there is no effect in what? In your maybe in your research, okay, or in your statement, okay. We shall see examples, don't worry, which will help you to do what? To understand more. Then we have alternative hypothesis. So for alternative hypothesis is the other, and all it's a complement. Let me say it complements null hypothesis. Alternative acts as a complement for null hypothesis. That's why we are saying that alternative hypothesis is the other answer to your research question. It claims that there is what? There is an effect in the population. Often, your alternative hypothesis is the same as your research hypothesis. Okay? Yes, this always supports your hypothesis. Alternative hypothesis always supports your what? Your research hypothesis. But that is a null hypothesis always tries to do what? To reject your what? Your research hypothesis. In other words, for alternative, it's the claim that you expect or hope will be true. Okay, that is, it shows that your claim or your hope will be what? True. Why? Because it is showing that maybe there is an effect. Okay, and then for, you can see now, for null hypothesis is trying to reject and saying that there is no significant difference or there is no effect, okay, in your research. And the alternative hypothesis is always denoted by that is HA or H1, and shows that there is effect in what you are trying to that is to study. Then we have 5 major steps in what? In doing hypothesis testing. Okay, and I want us to go that is step by step for this. That is for hypothesis testing. Once we are done with these steps, 5 steps, we will be done now with what? With the hypothesis testing. Okay, and then maybe in future, when you are doing a research, you can always do what? You can always follow those steps to do what? To that is to make your hypothesis, okay, or to come to a conclusion of what? Of your hypothesis. Okay, good. Now, the first that is the first step is to state your null hypothesis and alternative hypothesis. So in your research, you have to state the null hypothesis and the alternative hypothesis. So definitely for the null alternative, that is hypothesis, will try to show no significance difference in your what? In your research. And for alternative, will try to support your research topic. Then after that, you do collect data in a way designed to test the hypothesis. Okay, and then after that, you can now perform what? An appropriate statistical test, either maybe finding the what? The p-value. Okay, but you can now perform an appropriate statistical significance. Okay, now whatever the value of if maybe, remember, we are using, if we are using the p-value, okay, that is of 0.05, okay, and then in your alternative you get maybe a statistical significance of 0.002. Definitely this value will be what? Will be less than the p-value. And if it is less than p-value, then we will support your alternative what? Your alternative hypothesis, and say that we really have a significant difference, okay, between what? That is in your study, okay, or between two that is objecting what? Statements, okay. And then if we get any value greater than this, then we shall go with what? Null hypothesis. Okay, right. Let's now go. That is we will also perform an that is a statistical test. Then the following step will be to decide whether to reject or to fail. That is the null hypothesis. So in this case, in hypothesis, we either accept or reject null hypothesis. So if we reject the null hypothesis, then we are assuming that the alternative statement or the alternative hypothesis it's true, okay, or is correct. Or okay, if we try to accept the null hypothesis, then we are showing that we have no significant difference, okay, between what? Between our two statements which we are trying to what? To that is to test, okay? Then after that, the last step it's always now to present the findings in that is in your results or and the discussion section. Okay, that is in your research. Let's start with the first step. Okay, so our first step is stating null and alternative hypothesis. So after developing your initial research hypothesis, okay, that is the prediction that you want to investigate, it is important to restate it as a null hypothesis and that is alternate hypothesis, so that you can test it mathematically, because hypothesis null and alternative hypothesis, they are always that is statements, okay, they are generally statements. Now for us now to change these statements into meaning, we have now to test them mathematically, okay, we have to test them mathematically. So let's continue. That is the alternative or alternate hypothesis is usually your initial hypothesis that predicts a relationship between what? Between two variables or between two statements. Okay? The null hypothesis is a prediction of non-relationship between what? Between the variables you are interested in. Okay, good. Now, let's start with hypothesis testing example. Okay, let's work with an hypothesis example. Okay, the example, maybe we want to test whether there is a relationship between what? That is a certain gender and the what? And the height. Okay, so we can say that maybe men are on average not taller than women. Okay, yes, let's just try and see if that will make sense. So based on your knowledge of human psychology, that is physiology, you formulate hypothesis that men are what? Are of average, or they are on average, or they are averagely taller than what? Than women. Okay, so we are trying to formulate an hypothesis that men are what? Averagely taller than what? Than women. Okay, so this is our statement, this is our hypothesis that men are averagely taller than women. Okay, taller than women. Okay, so this is our hypothesis. Okay, this is our research hypothesis, or what we are trying to that is to research. Okay, so now in our research we'll be now researching if really men are taller than women. Okay, then this will be our alternate or our alternative, that is our alternative hypothesis. Okay, this will be our alternative hypothesis. Then what will be our null hypothesis? So remember, null hypothesis tries to show that there is no difference. Okay, So definitely it will now be like the opposite, that men are averagely not taller than women. Okay, men are averagely not taller than women. So this will be our this will be our alternative, and then we will also have our null hypothesis. Okay, so in this case our hypothesis will be men are not taller than what, than women, but our alternative hypothesis will be trying to accept what, our research topic, or our what, our hypothesis that men are taller than what, than women. Okay, good. Let's also check another example. You test whether a new drug that is in intervention that is can alleviate symptoms of an autoimmune disease. Okay, so what will be what will be our null hypothesis? So our null hypothesis will try to show that there is no effects, okay, or there is no symptoms, okay, that will that the drug will alleviate, that is on what, on an that is autoimmune disease. So our null hypothesis will be that the new drug has no effect on symptoms of the disease, and then the second one will be supporting, like is that the drug is effective for that is for alleviating symptoms of what, of the disease. So you can see this one is not supporting our hypothesis, but this alternate hypothesis is supporting what, our hypothesis. So like for null hypothesis, totally tries to do what, totally tries to that is to show that we really don't have any difference. Okay, we really don't have any difference in our what, in our that is in our topic, okay, or in our statement, or in our hypothesis. Okay, yes, so that was the first step, to formulate an hypothesis, that is a null and alternate hypothesis. Okay, it's like maybe we are having a statement like we are doing an IQ test, okay, between maybe statisticians and the that is the motorists. Okay, so we are assuming that the motorist did not go to school. Currently you might find even motorists who have completed that is um, university or college are what? They are motorists. But now with that, it will give us what? That is some outliers, okay, in our data. So our assumption is, okay, the motorists will have low IQ, okay, compared to what? To that is to the statisticians. That is our alternate that is our alternate hypothesis. Okay, but for no, that is for null hypothesis, it will try to show that there is no difference, okay, in IQ between the motorists and the what, and the statisticians. Okay, yes, so that's also another example which we can what, we can formulate an hypothesis. Okay, yes, then the second part is, now we collect the data. So for a statistical test to be valid, it is important to perform sampling and collect data in a way that is designed to test your hypothesis. If your data are not if your data is not that is representative, then you cannot make that is a statistical inference about the population you are interested in. So you must have some data, okay, because we'll have to that is to compute some statistics, okay. Like for example, hypothesis example that the tests yes, Eric. Eric, I can see you have raised your hand, or is still a mistake? Okay, all right, it's still a mistake. So, hypothesis testing example. Okay, so to test differences in average height between men and women, your sample data should have an equal proportion of men and women and cover a variety of socioeconomic classes and any other control variable that might influence what? Average height of what? Average height of a person. Okay, so in this case you will have to take what? That is data that is average height data for men and women, considering what? All these factors, socioeconomic classes, or any other factor which might influence what? Which might influence the height of a person. Okay. Yes, so you can see here we are dealing with what? Now the sample data of the average height of of the men and what? And women. So once you now collect the data, okay, we have a stage of now collecting the data. After now collecting the data, you now perform what? Perform a statistic. Okay? Now definitely here now we'll have some computations. Okay, we'll have some computation. So that is under this step. Okay, we are told to perform a statistical test. So we have all the variety of statistical tests available, but they are all based on the comparison of within group variance, or how spread out the data is within a category. Okay, so here we'll be trying to check what? The variance. Okay, we'll be trying to calculate the variance, okay, of what? Of these two that is data set. Okay, like the data for the data set of that is between the height of men and the height of the women. Okay, then versus the versus between group variance. Okay, which is how different the that is the categories are from what? From one another. Okay, so if the group variance is larger, okay, enough that there is a little or no overlap between the groups, then your your statistical test will reflect that by showing what? A low p-value. Okay, yes, if at all we don't have that big difference between the standard that is the standard variance for that is for men height, okay, and standard deviation for women height, okay, meaning we have a very small or that is no that big difference, okay, then it means we'll have what? A very low p-value. Okay, we'll have a very low p-value. This means it is unlikely that the difference between these groups came about by chance. Okay, nice. So if we have a very low that is value, okay, if we have a very that is small value of that is of a that is of the p-value, then we will try to move with what? we'll try to move with a null hypothesis, but just I don't want to make that decision at that point, okay? Because we are still at the at the topic of statistical test, okay? Alternatively, if the difference, okay, it is what? It is high. Like when we have I that is a difference in the standard or we have I variance between the what? The height of men, the average height of men and the average height of women, okay? Then your statistical test will reflect a high value of what? Of p-value, okay? Or it will have a high p-value. This means it is likely that any difference you measure between the two groups is due to what? To a chance. Okay, so your choice of statistical test will be based on the type of variables and the level of measurements that is of your collected data. Okay, so here, if maybe your p-value is low, okay, or your p-value is high, what happens? Okay, how do we infer this? If we are having a low p-value and if we are having a p-value, how do we categorize that is our hypothesis test? Do we either accept it or reject it? Okay, yes, let's try and see. Now under decide whether to reject or fail to reject what? Your null hypothesis. Okay? So based on the outcome of what? Of your statistical tests, you will have to decide whether to reject or fail to reject the what? The null hypothesis. So if we reject the null hypothesis, then it means we are supporting what? The alternative, that is the alternative hypothesis. If we are failing to reject the null hypothesis, it means that we are accepting the null hypothesis and rejecting the alternative hypothesis. Okay, so in most cases you will use the p-value generated by your statistical test to guide you make your decision. Okay, so and in the most cases your predetermined level of significance for rejecting the null hypothesis will be 0. What? 0.5 or 5%. So if we get that is a p-value of 5%, what do we do? Then we usually that is fail to reject, okay, the null hypothesis. We fail to reject the null hypothesis when we are having what? A p-value which is less than what? Which is less than 5%. So when there is a less p-value of or if our p-value is less than 5%, then the results we say that if the null hypothesis, that is your null hypothesis will be what? Will be true. Okay, what about in case maybe that is our value, okay, all our p-value is what? Is greater than 5%. Then with that case we'll have now to we'll have to reject null hypothesis in order to support the alternative, that is the alternative what? The alternative uh, hypothesis. Okay, so in some cases researchers choose more that is conservative level of significance, which minimizes the risk of committing what? Type 1 error. We shall see also the different two types of what? The two types of errors which we can make, or which we can that is commit when doing what? When doing hypothesis testing. Okay, you might find yourself rejecting the null hypothesis. Instead, you could have whereas you could have not rejected it. Okay, yes. Then we have the fifth step. Okay, so the fifth step, it's always now presenting your finding. Okay, the fifth step is now on presenting your finding. Okay, so in fact, let me try and see if I will complete it today, because we only have one slide remaining. Okay, we only have one slide remaining. So we have now to present our findings. Okay, now how do you present your finding? You present your finding by doing what? By doing the conclusion. Okay, you already have decided to either reject or fail to reject what? The null hypothesis. Okay, so now you will have to make what? Your conclusion. So in case maybe I reject the null hypothesis, then it means there is what? Like for the example of what? For the example of that is the average weight, that is height. So if I reject the null hypothesis, meaning I'm in support of the what? Of the alternative that is hypothesis, then I will conclude that it's true that men are taller than what? Than women. Okay, but when I fail to reject the null hypothesis, that is when the p-value is less than 0.05, when we are saying that when the value of p is less than 0.05, the null hypothesis is true, then we will say that for sure men are not what? Men are not taller than what? Are not taller than women. Okay, that is when you accept the null hypothesis, will basically mean that men are not taller than what? Than women. But if that is we reject it. Okay, if we fail to reject null hypothesis, is when we are saying that there is no that is the difference in height. Okay, that is between men and women. Like it's like we are saying that um, there is no significant difference, okay, between the height of men and what? And women. But if we reject the null hypothesis, then it's like we are saying that is male that is men are taller than what? Men are taller than women. Okay, okay, that's our objective. So the results of hypothesis testing will be presented in the results and discussion session of your research paper and dissertation of what? Of your thesis. Okay, in the results section you should give a brief summary of the data and summary of the results of your what? Statistical test. For example, the estimated difference between group means and the associated what? P-value. In the discussion, you can discuss whether your initial hypothesis was supported by your results or not. Okay, so in formal language of hypothesis testing, we talk about rejecting or failing to reject the what? The null hypothesis. So if you are in support, then you do what? You either reject or fail to reject the null hypothesis. But you can't say we are accepting alternative hypothesis. Okay, when we reject that is when trying to infer. Okay, but always use the term rejecting or failing to reject, rejecting or not rejecting. Okay, then we have some two type of errors which we can that is which we can commit. Okay, two types of error which we can commit when doing hypothesis testing. Why? Like one error, you might reject the null hypothesis when you were supposed to not reject it. Okay? Or you might not reject the null hypothesis when you were supposed to what? To reject it. Okay? So with that, we have now that is two types of error. That is type 1 error and type 2 error. Okay? What about type 1 error? So in statistics, a type 1 error, it's a false positive conclusion. A false positive conclusion. Okay? And then type 2 error, it's a negative, that is a false negative conclusion. Okay? A false negative conclusion, type 2, and type 1, it's what? A false positive conclusion. What do I mean? Making a statistical decision always involves uncertainties. Okay? And if we have uncertainties, so there is risk of making these errors, all the risk of making these errors are unavoidable in what? In hypothesis testing. Like for example, let's maybe you have decided to get tested for COVID-19, that is symptoms. Okay, so here there are two types of errors that might potentially occur. Okay, like type 1, false positive. The results or the test results says you have coronavirus, but you actually don't, because here we are just checking what? We are just checking symptoms. Maybe those symptoms might not be coronavirus symptoms. Okay? And maybe if we use, let's say, two symptoms like eye fever and maybe headache. Okay? Also, malaria can come or can have those two side effects. Okay, so with that, you'll be able to do what? To make a false positive conclusion. Like you are saying, you are that is the results are showing that you have COVID-19. Okay, all the test results says you have COVID-19 virus or coronavirus, but you actually don't have. Okay, what about type 2? Type 2, it's false negative. Like the results might say that you don't have coronavirus, but you actually do. Let me put this way. Like your symptoms, type 1, let me start with type 1. Your symptoms might try to show that, might show that you have what? You have coronavirus, but truly you don't have coronavirus. Maybe those were symptoms of another infection. Okay? Good. What about type 2 error? Type 2 error, you might now conclude that you don't have coronavirus, depending with what? With the symptoms which you have portrayed. Okay? You might say that you don't have coronavirus, but actually you do have it. Okay? So these are two these are two types of errors which we might commit when doing hypothesis testing. Let me take the example of the height of men and women. Okay, you might conclude that women, okay, have what? Women women are taller than what? Than men. Whereas actually maybe that is the true result is that men are what? Men are taller than what? than women. You can also conclude that men, okay, men are taller than women, but you find that in real case, okay, women, we have some that is women are what, are taller than what, are taller than men, okay, and that definitely will be contributed by that is by different factors, okay, they will be that is they will be contributed by that is many factors, okay, like the socio-economic classes, okay, yes, and also we know in maybe some tribes or in some countries we have even women, taller women than men. Okay, all right. I guess that's a brief explanation of the hypothesis testing. Okay, so the objective was just to define hypothesis testing and understand what hypothesis testing is, then study about that is two types of the hypothesis testing, which is the null hypothesis testing and what, and alternative hypothesis testing. Then after that, maybe go through a symbol, all the standard what, the standard method of what, of doing hypothesis testing. Okay, a standard way of doing hypothesis testing. Then after that, you now do what, you now do your conclusion. We have the 5 steps of hypothesis testing. Okay, you can go and maybe learn more about that, but basically the objective was to know maybe the different types of different types of hypothesis testing, and how maybe all the steps to to do the hypothesis testing, and then also two major what, two major errors which you can commute that is which you can commit when doing what, when doing hypothesis testing. Okay, and that's all about hypothesis testing. Okay, you can go and learn more that is more about hypothesis testing, maybe to understand maybe where you find a gap, okay, or yes, just to